For Activity 5.7, we're going to be learning about some new Inventor features that we haven't used yet. If you go into Canvas under Activity 5.7a, you'll see that's CAD Modeling Features Part 1, and you want to make sure that you grab this activity sheet and either download it or click on the magnifying glass here to view that document in Canvas itself. The requirement sheet will be handed out to you in class, and that is going to be a document that's going to be required to be initialed by the instructor for each of your parts. So you'll see that we have a total of 7 parts here, and you'll need to get initials and date from your instructor, and then you'll need to complete the conclusion questions on the front and the back, and this will be your submission to Canvas for this assignment. So if we go to our activity sheet, which I have it pulled up here, the first part that you are going to make is this rubber handle sleeve, and we are going to use, if you look at the top of the page, we're going to use the revolve command. In this first part and also the second part, which is the axle, we'll both use primarily the revolve command to complete these parts. So the first thing we need to do, though, is take a look at the activity sheet, and you'll see that we have a 3D dimension drawing at the top of the page for the rubber handle. And we also have a 2D drawing at the bottom with some dimensions, and then we also have some blanks. These are dimensions that you have to come up with on your own based off of the dimensions of the 3D model above. So if I go ahead and zoom in here a little bit, we can see that this is our handle, and this is a cross section of our handle. So if we took this thing and split it in half, this is going to be our cross section. And in order to make this part, we are going to have to create the bottom part of this cross section, or the bottom half of this cross section. We will then take that shape and revolve it around this central axis, and that's going to help us create this part. Now, the one thing you'll notice between the 3D dimension drawing and this 2D sketch is that the corners on this 2D sketch do not have fillets on them, and they do up here. These you'll add later using the 3D fillet command. But the 3 dimensions that you need to find out are these blanks. So if you take a look at this first one here on the left-hand side, you'll notice that the dimension it's asking for is the distance between this central rotation axis, which should be a construction line, and the top of the profile. Now if we zoom in here at the top, we can see that the handle has a very small hole at the top of it, and the diameter of that hole is 0.1875. To find that distance between this central rotation axis and the top of this part, all we need to do is take half of the diameter. The diameter is the distance from the bottom of this hole to the top, and we need half that distance to get us the correct dimension. So when we go and plug this in here, it would be 0.1875 divided by 2, which should get us 0.09375 would be this dimension here. This second dimension in the middle is asking us for the distance between this central rotation axis and this outside line. So if we scroll up and take a look at our sketch, you'll notice that this shape is a cylinder. So the way we dimension a cylinder is through diameter. And you'll see over here on the right hand side, with this entire cylinder has a outside diameter or overall diameter of 1.375, and that OD stands for overall or outside. So that means that from the top of this cross section to the very bottom, that distance is 1.375. So to get the distance from the center axis, or this line of symmetry, to the bottom, we would just need to take that once again and divide it by 2. So if you come down here, this distance, if you take 1.375 divided by 2, should get you 0.6875 for this second dimension. And then this third dimension is just the thickness of this wall. So if we go up to the top, since this is symmetrical, it's the line of symmetry, we can see that the wall thickness up top is 0.25, so the wall thickness below will also be 0.25. That'll allow us to come down and fill in the third and final dimension, which is 0.25. Now that we have all those dimensions, we can go ahead and go over to Inventor and make our sketch. So I'll go ahead over here and open Inventor, and I'm going to go to New and create a new standard IPT. Now the first thing I'm going to do is create a new sketch on the XY plane. And I'm going to drag this over so my origin's in the bottom left, and I'm going to zoom out just a bit. And the first thing I want to do is create my central rotation axis. which should be a construction line. So I'm going to grab the line command, and then I'm going to go over to my format panel and turn on the construction line option. And I'm going to start at the origin here, and I'm going to make a line on here. Now this line, the length of this line is irrelevant, but because my overall shape is just under 5 inches, I'm going to go ahead and make this 5 inches just so it covers the length of the entire shape. And I'm going to hit enter, and I'm going to right click and OK, and you'll notice that that line is dashed. So the next thing I need to do is create my profile. So if I go back and look at my shape here, I need to create this L shape. So you could use the line command and draw this box. For me, I would rather use a couple rectangles, so I'm going to grab a rectangle and I'm just going to approximate where these go just so they're roughly the right size. And I'm going to make that box right about there. And the second rectangle, I'm going to snap to the bottom right corner, and I'm going to drag one down so I get the approximate shape. Now, if you notice what happened, these lines are construction lines, which I don't want, and you may accidentally do this. If you don't go back and uncheck construction lines, it will make everything you make a construction line. So in order to quickly change this without deleting it, if we just click and drag and select that, and then we can uncheck construction, and that'll make those object lines again. Now it is going to turn the construction line back on, so just make sure that that's unmarked, and it should not be blue. If it's blue, it's selected. So the next thing I'm going to do is go in and add all my dimensions. If I go back and take a look at my part, I know this dimension here was my 0.1875 divided by 2. So I'm going to go ahead and add that dimension first. So I'm going to grab my dimension command. I'm going to dimension from that rotation axis to the top of this rectangle. And I know that's 0.1875 divided by 2. Might as well let Inventor do the math for you. And I know that's 0.09, and it's actually 0.09375. Inventor rounds this up a little bit. My next dimension I know is the width of this part here, which is 0.156. So I'll grab my dimension and dimension the width here as 0.156. My next dimension I know is going to be the overall length of here, and if I go back here, I can see that the overall length from the far left to the far right is 4.469. So once again, grab my dimension from left all the way to right, and that's going to be 4.469. Hit enter. And then the last, or two more dimensions I need to make are the thickness of this wall here. And if I go back here, I know that this one, based on my drawing above, should be 0.25. So I'll go back to Inventor, and I'm going to dimension the wall here as 0.25. And then the last and final dimension I need to add is the distance between the rotation axis and this outside wall. And I know that, if I go back here real quick, I know that that dimension is this 1.375, which is the overall diameter, divided by 2. So I go back to Inventor, add my dimension from the rotation axis to this outside wall, and I know it's 1.375 divided by 2. Hit enter. And now I have my shape that I need to go ahead and revolve my part. So I'm going to go ahead and finish the sketch. I'm going to grab my revolve command. And the first thing it's going to ask me for is to select my profiles. I use 2 rectangles, so I have 2 profiles, that one and this one to select. If you use the line command, it would all be 1 profile. Then I need to click on axis and select my rotation axis. And as soon as I do that, it's going to show my solid shape. And I'm going to hit OK. And if I rotate around this, I should have that small hole up top and the larger one on bottom. So this looks good. After I have that done, I want to go to my fillet command. And I want to change my radius to 0.25. And I get that from my 3D sketch here where it says my radius is 0.25 TYP, or typical, which means both radiuses, this one on this end and this one on this end, are 0.25. And then I'm going to select that circle there and this circle here, not the interior but the exterior circles. And that's good. And I'm going to hit apply, and that'll apply my 0.25 inch radius. Now we do a 3D radius instead of a 2D radius because if I needed to change this to a different radius or just get rid of it, if I did it in sketch mode, I'd have to open the sketch, edit it, delete it, add the corners back if I wanted to have sharp corners again. Whereas if I use the 3D fillet, I can double click on it, quickly change my dimension. To change that, I want to keep it at 0.25, so I'm going to go ahead and put that back to 0.25. Or if I wanted to delete them, I could right click on it and just delete them and get rid of it without having to go back and edit a sketch. I'm going to hit undo just to add that back. Once you have this done, your part is complete. Make sure you go to the colors and scroll down to rubber and black. And then you will want to make sure you go and save this part to your 5.7 folder that you should have created in your IED folder for this activity. Now we're not going to go through the axle step by step here, but I want to scroll down through our activity sheet until we get to the section for the axle, which is number 2. And you get this sketch here. And let me zoom out just a bit. Now a couple tips here. When you're creating this, you're only going to create one side of it. And also you'll notice that the dimensions it gives you for your heights are in diameter. So it's the dimension from one side to the other. So once you go in to start figuring out what these thicknesses are, you're going to need to change these dimensions as if they're coming from this central rotation axis. So to do that, to get your diameter down to the radius, you would just have to halve it or divide by 2. And that'll get you the distance from the central axis to whatever point it's showing. So for this 0.19 here, from this central axis to this point would be 0.19 divided by 2. For the 0.4 here on the overall diameter, it's going to be 0.2 from the central axis all the way to this outside edge. So make sure you go through and divide all these by 2 so it makes it a little easier for figuring out what your dimensions are. And you're still going to have to do a little math even after that to figure out what some of these are. You'll have to add and subtract from one another to figure out your dimensions. Additionally, you're going to want to make sure that when you create this, you do not use rectangles like I've shown in the past. Rectangles create a lot of constraints, which is going to cause some issues when you go in to create this and add all your dimensions. My suggestion would be to either start at this point at the bottom of this slanted line, and this is a slanted line here. So either start at this point and work your way counterclockwise around the part using the line command, or start at this point, which is the top of the slanted edge, and work your way clockwise around this part and create those shapes and then go back and dimension them. That's going to be the most effective method of creating this, and it's going to provide the least amount of issues later on when you go to add all of your dimensions. Once you have this done and you revolve it and get this solid shape, there's still this hole or this slot to cut out that you'll see in this 3D shape. In order to do this, all you're going to do is create a rectangle and extrude through to cut that. But in order to do that, you're going to have to create a work plane that is tangent to this cylinder. And it doesn't really matter where it is because everything else is symmetrical. You just need to create a work plane that's tangent, and it will have to be tangent to this lip here. And you'll create that work plane that's tangent to that lip, create a rectangle, and then extrude and cut through that all the way through both sides, and that'll create that slot based on these dimensions. If you have any issues with this, check with your instructor. Once you have all these parts done, or both of these parts done, make sure you save them to your 5.7 folder and move on to the next parts.